So what do we got? Let me go over here. We got 5 to the power of 2 over 3. The way it works is that 3 in the denominator moves to the radical in front of the 5, okay? It'll be like 2 more minutes. Okay, awesome. So the way it works is we got a skater over there who wants to skate. He's being nice, taking a break. So what we got is 5 to the power of 2 over 3. And what it does is it grabs the 3 in the denominator and moves it to the front of the 5, and it becomes the radical, okay, the root symbol. So that's the way rational numbers work. So basically with the natural numbers, if you put anything from the natural number set in the exponent, it clones itself. The number of times it says you should clone it. If you put anything from the whole number set, it clones it if it's one of the natural numbers, which is 1, 2, 3 all the way to infinity. And if you include the 0, if you put a 0 up top, it makes whatever is here, the whole thing equal to 1. If you go to the integers, with the integers, it flips it. With the rational numbers, it puts it in the radical. And it basically becomes the root of. Now, I'm going to do a lot of examples with this stuff. And hopefully you can see it. I'm going to start off slow and break it all down. With the irrational numbers, you just put the irrational number there. If it's negative, then it flips it if it's an irrational number. Irrational numbers are, you know, they're a special case. So we're going to deal with those later. They basically include everything here. You just can't do it as nicely. You break it down and stuff. Well, you can't. You need a calculator to do it, or you got to be really good at doing it by hand. Okay. So this is basically our real number set applying to anything in the exponent, and exponents are basically radicals. Okay. So exponents are radicals. They come from the rational number set. Okay. We're going to do a lot of problems with these things. Because I know it sort of becomes complicated, and you've got to be really good at simple algebra, which is just basically addition, multiplication with fractions, and just break it all down. Because it's, again, like I said before, you have to be able to massage numbers, break them down, and really understand the real number set, because this whole thing, this real number set is majority of the numbers, should be almost all the numbers you deal with in high school, except if they introduce imaginary numbers, the square root of a -1, of negative numbers, basically. So the real number set it's crucial for you to understand this because it applies everywhere. One of the first places it applies, it breaks it down into its different sections in the exponents, which is, again, a huge part of high school mathematics, where you have to learn how to break numbers down. And all of this whole thing is really dependent on, not dependent on, but it's really important for you to know the prime numbers, because you use prime numbers, you break things down basically based on their prime factors, especially in the rational numbers in the exponent, which becomes radicals, the root of, the cube root of, square root of, the fifth root of, whatever root of. Whatever number is in the denominator, we're over here. Whatever's the number in the denominator goes to the radical. So whatever you put there, that's the root you want. So all of that is dependent on you being able to break things down into their prime trees, prime factors. Okay, super important. We're going to do a lot of examples with this. Hopefully this made sense. I had to do this real quick. I've come here like 4 times, and it's always been busy, so we had to get it done. We had a little lull period there, okay? So go through this, and we're going to have a lot of examples coming up with the videos, okay? Exponents. Okay. Yeah. So basically it's broken down into natural numbers, whole numbers, integers, and rational. And each one does a special thing.
Who says that down here goes 1, 2, 3 clones itself, it repeats itself?
Yeah.
What did you say?
Yeah, so it does. You want me to show you?
Yeah.
Yeah.
That's right. All right, see you later, buddy. Yeah. Oh, this part. All right. That's right. All right.